Hey everybody, today we're doing another example of hypothesis testing for the mean because we just can't get enough practice at this one. Before we get to an actual example, let's run through the general procedure. We're always going to start by setting up hypotheses. A null hypothesis, generally the thing that we're trying to get evidence against, and the alternative hypothesis, the thing that we want to get evidence in favor of. We're going to assume the null hypothesis is true, and then we're going to consider where our sample mean, x bar, falls in the context of all the possible sample means that we could have gotten under the assumption of the null hypothesis. We do that by computing a z-score. Big z-score in absolute value indicates that our result is surprising in the context of that null hypothesis. More specifically, if we're testing the one-sided alternative, mu less than some number, we're going to compute the probability of randomly getting a z-score less than or equal to the one we got. If we are testing the alternative hypothesis mu greater than some number, we'll compute the probability of randomly getting a z-score greater than the one we got. And if we're doing a two-sided alternative, basically we could do either one and then double it as long as we do it in the appropriate way. The most formal way to write this, and this is a procedure I'm going to stick to, that we're going to find the probability of getting a z-score less than or equal to negative the absolute value of z. So basically just take the z-score and make it negative, and then get the cumulative distribution function of that, and then double it. And that, when you double it, that takes into account the area, not just to the left, but also to the right of the cutoffs on the left and right. Finally, once we have a p-value, we're going to compare it to our alpha. If p is less than alpha, the significance level, then we're going to reject the null hypothesis and conclude, in fact, that the alternative hypothesis is true. Let's actually do the example. A consumer advocacy group tests the vitamin C content of an organic supplement that claims to have an average of 1,000 milligrams of vitamin C per tablet. In a sample of size 32, they find a sample mean of 1,008.9 milligrams. Assume a population standard deviation of sigma equals 21 milligrams. Is there enough evidence to reject the product's claim? And we'll test at alpha equals 0.05. So if we get a p-value less than that, that's going to signal that we should reject the null hypothesis. As always, our first step is to set up hypotheses. Our null hypothesis is that the product's claim of an average vitamin C content of 1,000 milligrams is true, and that my sample mean is different from it just through luck of the draw, just through random chance. We know that not every pill is going to have exactly 1,000 milligrams. Some will be a little high, some will be a little low. This is the idea that we just happen to get 32 tablets with a high mean. Alternatively, we're going to be looking to gather evidence in favor of the idea that that parameter mu is not 1,000. Here, we're not given any reason to think that we should only consider values less than 1,000 or greater than 1,000. By default, we consider both with the two-sided alternative hypothesis. Let's actually do some calculations. So the next step is to get a z-score. The formula for the z-score is the value we got minus the value we expected over the standard deviation. The only subtlety here is that we have to remember we're talking about the expected value in the standard deviation of x bar in the context of the sampling distribution of that sample mean. So we've assumed the null hypothesis, so we're going to use mu equals 1,000 milligrams. We are given that the population standard deviation is 21 milligrams. So if that's the variability of individual pills, then we can get the variability of samples of size 32 by taking 21 divided by the square root of 32, the standard deviation for the population divided by the square root of the sample size. Overall, the z-score comes out to be 2.39. Our sample mean of 1,008.9 milligrams is 2.39 standard deviations over the mean value that we would expect if the null hypothesis is true. We need to know the probability of getting a z-value, at least that extreme, either positive or negative, so an absolute value. To compute this using R or a TI-83 calculator or most online calculators, we need to write this in terms of a probability of z less than or equal to something. So we'll write we're going to write p of z less than or equal to negative 2.39. So the probability that z is less than the negative version of that z-score that we have. When we do that, we get 0.0084. Since we're doing a two-sided test, we got to double that to get 0.0168. That's the probability of getting a z-score greater than 2.39 or less than negative 2.39. And it's the latter of those two that I calculated and then doubled. Since this p-value is less than the alpha we set of 0.05, we have sufficient evidence to reject the null hypothesis and accept the alternative hypothesis. We conclude that the supplements do not, in fact, contain 1,000 milligrams of vitamin C on average.